In this project, we consider the dimensions of fractal sets, specifically those generated by the sequence of 10 maps. The fractals generated are the sets of points that remain in the interval as we repeatedly apply the 10 maps. These fractals are like the classical Cantor set, but with more flexibility since we can vary the compression at each step. We measure their complexity using two types of dimension, the Hausdorff dimension and the box counting dimension. Since these 10 maps are linear, that makes the dimension much easier to compute than more complicated systems.
So for our results, first, we simplified the proofs for the exact formulas for both the Hausdorff and box counting dimensions of inverse map systems, and showed that they depend on the parameters of the system that generates the fractal. We also proved that these dimension formulas are Lipschitz continuous, meaning that small changes in the parameter sequences that generate the fractal lead to controlled changes in the fractal dimensions. Linearity of tent maps helps simplify our proofs compared to more general cases because the uniform scaling at each step allowed for exact calculations of interval lengths and measures.
Lastly, we also consider what happens when we sum the Cantor sets. We were able to find two bounded sequences such that the sum of the Hausdorff dimensions of these sets is less than 1, but the sum of the sets is the full interval 0 to 2. This is significant because in autonomous 10-map systems where the sequences are constant, the box counting dimension and the Hausdorff dimensions coincide. In this case, the sum of dimensions being less than 1 does imply that the sum is another Cantor set, meaning it has length 0. Thank you.